Hi, my name is Samantha Brewer, and I, along with my teammate Brian Fredrickson, are going to be going through what we completed for Sprint 5 of our Capstone Cyber 1 code version. To give an overview of the project, our goal is to automate generation of obfuscated semantic clones, where the output source code functions the same as the input while being visually distinct. Our roles that we had for this sprint was me creating functioning GUIs and implementing language translation that is offline and disconnected from any external API or LLM. And Brian would continue development on logic obfuscation, which would be swapping while loops for for loops and vice versa as an example. Our main goals for Sprint 5 were to create a complete working demo of the GUI, finish implementing offline language translation, and expand coverage of logic obfuscation to more expressions and loops.
So some of the main objectives that we had for Sprint 5 was to enhance the capabilities of the GUI for ease of use for the end users. So when cybersecurity professionals first come in contact with the user interface, it's clear for them how to use it. Diversify outputs for semantic clone files to promote uniqueness of solutions. So that's providing branching of different probabilities of changes to certain pieces of logic and code. Providing functionality for multiple language coding style types and source files. So, an example from English to Arabic and vice versa, and with the Argos language package, that'll be provided to do that. We also have automated Python file obfuscation process. So we have for our system testing, we have Python files that integrate all the changes and all the different types of logic that can be logic changes that can be made. So we can test all of this for unit testing. And we have functionalities of GUI libraries and congruence with backend obfuscation logic. So we started with the backend, and it was fairly simple to integrate to the front end and how we interact with it using user interface techniques like buttons. So yeah.
As stated earlier, the primary features we wanted to focus on for this sprint was a fully functioning GUI, offline language translation, and basic logic obfuscation. When it came to testing and validation, we tested generation parameters to try and see if we could circumvent validation in the GUI, as well as testing individual logic edge cases. Prior to this sprint, clone generation was done via terminal or Python notebook file in Google Colab, and now it runs in simple GUIs with clear parameters and strong parameter handling. While variable and function renaming, query Gemini API with backup word banks of color and animals, while now it can translate it into functional, completely accurate foreign language representations. So when it comes to using our program, first you begin with the Argos Translate installer. So running it now, you can see I have 0 languages installed. So I would go to the Argos Translate installer, which will open a GUI. And from here, I can select multiple different languages to set up. So for now, I am going to choose Spanish and let's say French. So it says languages to install 2. So I will begin installing these. I've chosen these simply because non-Latin alphabet languages are causing some trouble with our program. It remains fully functional, but as it is, we simply have it so that it translates these language outputs into random Latin characters so that they can still work in Python, and we are working to fix that. But you can see installation complete for both French and Spanish. And so after this, we are able to move on to the Python obfuscator itself. And from here, we can go ahead and run it. It takes a little bit to start up just because it's currently installing all those languages and just setting everything up. But once it's pulled up, again, it takes a little bit. It's pulling multiple things, including common abbreviations and so on. So now that it's pulled up from here, you can select input files. So I'm going to simply choose a test file, func names complex. This is what we used previously for the variable and function renaming. So it pulled up output directory. Let's just say this current directory. Clones to generate 2. Currently disabled logic obfuscation simply because it doesn't cover all the edge cases, and we haven't created robust enough error handling for it yet. Source language, the input of the source code is English because it doesn't have dynamic language testing. This was something requested by our client just because it could slow down generation time. And then when it comes to renaming functions and variables, let's just say 100% for both. And output languages, we can try and select English. And when we validate, it'll throw an error for this because it's not actually translating. So we select French and Spanish. There's other strong validation. So when we validate parameters, it shows that the input file is syntactically valid and therefore can be converted to a functional file. So given that all the inputs are selected and correct, we can hit generate, and you can see that it's generating these clones, and it selected the output language as Spanish for this current one, and it is currently run through very quickly. And it generated the two, so you can see the second one was French. Variables renamed 10 out of 10, functions renamed 4 out of 4, and logic obfuscated. It says 0 simply because we disabled it, so it's not looking for that. And so now if we close this and go to the obfuscated functions, we can see that it has been translated. You can see here, for example, that this is French and this one is Spanish. So that's mostly the variables being renamed and such. Some of them are going to be the same because this is actual language translation rather than using word banks and random words. And if you try to run it, you can see it's still functional for both. And that is our GUI so far. We are still working out a couple of issues and trying to expand it more next sprint, such as including output logs that show more details of what has been changed, so you can see that back-to-back changes and be able to verify that these are unique and non-deterministic when generated.
So now I'm going to be discussing kind of the process of the deployment of the CyberOne code revision tool, and some advice from the client that we got. So rather than running the program exclusively in the Google Colab, the cloud environment, that was kind of challenging for the team if we wanted to collaboratively work on it at the same time. Language translation packages are installed offline, so everything, all the dependencies are located within the GitHub repository, and all you have to do is download the GitHub repository from the online site, and you can download all the dependencies offline. So the project repository along with the GUI dependencies can be downloaded from the client device and run without having to restart a new runtime environment. So that was another case that we had with the Colab. We had to install all of the packages and the dependencies every single time we wanted to run it at new runtime, which was very time expensive. So translating to the GitHub it improved our ease of use. So some of the feedback that we got off of our weekly meetings from Tashi was he was very satisfied with the process of downloading the prerequisite packages and automatically having it search your having it search your program files or your dependencies and check to see if it's actually on your system first, and if it's not, it downloads it for you using the Argos software installer that Sam implemented. And he also did suggest that for user purposes, that logging capabilities during semantic clone generation should be included to help the user understand the code changes. So this is more than just uh, the the logic obfuscation. This is letting the user know, how variables, functions are being renamed, the process of creating the semantic clone file, so the user is able to understand and see visually how the differences occur between the root file. So for the process of deployment, some of the new features were implemented on the Google Colab. So for larger, more extensive files, we used the Colab RAM and the GPU power. But other than that, we were able to run pretty much everything on our machines because it wasn't too expensive resource wise. While other features were done locally on the developer side and pushed to GitHub repository once it was functional. So that was kind of our CI/CD integration, just making sure everything's up to date. And once it's ready to go, then we push it to the GitHub repository to be integrated for the next feature.
For our Kanban board contributions, it largely follows the roles that we stated earlier, where I focused on the GUI and Brian worked on the logic obfuscation. So looking through what was completed and what wasn't, you can see that I completed all the issues relating to variable and function translation as well as creating GUIs, while Brian focused on logic obfuscation. For unfinished work, it builds off of what we managed to complete this sprint and just expands on it and polishes it for our final sprint. So Brian will focus on logic branches, logic obfuscation logs, and implementing try except to help try and circumvent these errors that can end up crashing the program if a function or other logic loop doesn't perfectly conform to what we are testing. While I also created new issues relating to fixing foreign alphabet translation, adding more output convention styles, so camel case and so on, because right now it only outputs in snake case, optimizing translation speeds, and implementing external log output to the obfuscator so that you can see what it is doing.
So now I'm going to be addressing the meeting minutes with the clients. So as you can see, we are directed here. These are all the meetings that we've had with Tashi over the course of the semester. This is our most recent meeting minutes, which I will show you here. So the agenda, we have a meeting summary, what we talked about, the client requirements for what we discussed for the sprint, some discussion points to of how we want to target and how we want to go about implementation of new features, some of the decisions made in terms of improving the process for the sprint. So an example here is use try except blocks because there was issues with the logic obfuscation. So we're going to transition towards that for next sprint. Some action items, so just tasks that are outlined and that we have to do. And yeah, the project milestones discussed, next steps, and we have our next meeting in 2 days. So that's a short recap of the meeting in minutes, along with the other ones here.
For our Sprint 5 report, you can see that we wrote what's new, which is mainly the Argos Translate Language Installer GUI and the Python Obfuscator GUI, as well as some logic obfuscation for binary operators and some other logic types. To expand on this more, we have multiple files that we created. You can see here, so there are 4 files for each. We're running on some required components just for running, as well as the programs themselves. And then for the Argos Translate Language Installer, a helper program that just shows what languages were installed, as well as coding abbreviations for the Python Obfuscator to translate abbreviations to their full terms. To build on that, you can see that in our completed issues and user stories, we created this GUI and we added logic obfuscation. And the incomplete user stories are basically new ideas that we came up with to help polish and improve our components that we have created so far. So you can see here that we also have a retrospective summary. What went well is that the deliverables are functional and they are polished. What we'd like to improve is better coverage of logic obfuscation and error handling. And for next sprint, to build off the issues that we created for more functionality that we want to create, we want to have debug logging and fully functional logic obfuscation and language translation.
So I'm going to be covering the sprint achievements and challenges from sprint 5. So some of the achievements we made for sprint 5 were there was a clear deliverable of installer programs and GUI for end user interaction. So this was the Argos package installer as well as the Python obfuscator graphical user interface. So a logic obfuscation foundation was built and the basic edge cases were covered. So that will be further implemented in the next sprint. And then function and variable renaming capabilities for multiple language types and coding styles. So that's the Argos installer package, and that's the implementation that Sam worked on. Some of the challenges that we encountered this sprint was understanding the method of returning modified nodes in CST for logic obfuscation, mostly just studying how you're supposed to return certain code snippets back into the module, for instance, from like for loops to while loops, understanding how that works. And then a tkinter wrapper on the Python obfuscator made it difficult to debug process errors in semantic clone generation. That's when we'll be implementing the logging capabilities to bypass the tkinter wrapper and actually see what the errors are in an output like log file. And then in terms of advancement for Sprint 5, language libraries are more efficient to install, and separate GUIs are provided to ensure prerequisites are met. And then the logic obfuscation foundation is built, so it'll be pretty simple to expand upon that.
For our next steps and the sprint retrospective, our upcoming tasks reflect the new issues we created to build off of our implemented features that we did for this sprint. To implement log outputs, better logic error handling, optimize translation, and expand translation variety. For implemented client requests, some examples include selecting random output languages on a per clone basis rather than per object as we previously were doing, and to remove costly input language detection, let the user specify what the source code is so that we don't have to check every time it's coming in and make sure that it aligns with what we are expecting. So it's done in good faith. For our sprint retrospective, what went well is that we created an accessible and functional GUI for end users. To improve, we need to add more types of logic to obfuscate and expand translation language support. Changes for next sprint to build off of this include fully functional logic obfuscation, improved translation, and output logs detailing changes made to the clone, as currently output is only done in the GUI itself and is transient so that when you close it, you can't see what a previous generation did.
To conclude the Sprint 5 video, we're going to conclude by wrapping up some of the things we talked about this sprint. We covered the sprint objectives, achievements, and the challenges faced in Sprint 5. We looked at some of the features, implementation, and a demonstration of those features. We talked about the client feedback and the deployment process of getting our software to the end users to be able to be used in a practical sense. And we also went over some Sprint 5 documentation review, such as the meeting of minutes, the sprint report, and other tasks that were performed in Sprint 5. And we're going to go, and then we also talked about the next steps in the sprint retrospective, moving on to closing out the CyberOne code version integration for the semester. We want to thank Tashi Sterawalt for being a mentor for this project and leading us in the right direction, and PK for encouraging us of what to do better for sprint reports and for future implementation of our project. Thank you for watching.